In this video, we're going to look at how to divide rational expressions. So remember, when you're dividing fractions, what you do is you flip the second fraction, you change the multiplication. Then you multiply across the top, and you multiply across the bottom. And then you will cancel out any common factors. So the process that we're going to use is make sure your numerators and denominators are completely factored first. And then what you want to do is flip the second rational expression. Remember, when you were dividing by fractions, you were actually multiplying by the reciprocal. Multiply across the numerator and denominator, identify your common factors, and cross them out. So this is the process we're going to use. The only difference between multiplying and dividing is when you're doing division, you have to flip and then change the multiplication. So you're going to see it's a skill. Dividing is a skill you should be confident with after the first step. So let's try a couple of problems. First off, I have 8x squared y over 15a squared b divided by 2xy squared over 5ab to the fourth. I see here that I am dividing two rational expressions where we have monomials. So what I'm going to do is flip the second fraction. I'm going to keep the first one exactly the same. So to flip the second fraction, the 5ab to the fourth goes on top, and the 2xy squared goes on the bottom. Now, I'm going to do this a little bit differently than what we did in the previous videos when multiplying rational expressions with monomials in the numerator and denominator. You can go ahead and multiply across the top and multiply across the bottom. What I like to do is I actually like to simplify from here. I like to look at what do I have in common in the top and the bottom. And if I look, I have an 8 in the top and a 2 in the bottom. So 2 goes into 2 once, and 2 goes into 8 4 times. I have a 5 in top and a 15 in bottom. Well, 5 goes into 5 once, 5 goes into 15 3 times. And I can go further with the variables if I wanted, but you look now, and I'm not going to go further with the variables because this looks a little sloppy to me. If I were to continue to cross out with variables, I would have a lot of red marks and a lot of little numbers written all over. I might not understand what my work is saying. So from this point, now I'm going to just combine them together. 4 times 1 is 4. And so I'm just going to put down 4 and put my variables in alphabetical order. I have a, b to the fourth, I have x squared, and I have y. On the bottom, 3 times 1 is 3. I have a squared, I have b, and then x, y squared. So sometimes it's nice just to rewrite the problem after you do a couple things so it looks nicer and it's easier to see what you need to do. For example, I see I have 1a in the top and 2 in the bottom. So the 1a can cancel here and 1a can cancel here. I have 4 b's in the top, only 1 at the bottom. So 1b can cancel here and here, which changes this to a 3. X squared over x becomes an x in the top. Y over y squared becomes a y in the bottom. So my final answer here is I have a 4b cubed x left on the top. I have a 3ay on the bottom. And there is my dividing of rational expressions, the answer completely simplified. In example 2, we see that we are doing division. What I'm going to make sure I make a note of is since I'm dividing, I have to flip this second fraction, and I'm going to change it to multiplication. I'm going to do that process in the same step as when I'm simplifying and factoring the numerators and denominators. So first thing I'm going to do is simplify x squared minus 6x minus 16. Two numbers that multiply to give me negative 16 and add to give me negative 6 are negative 8 and positive 2. I get x squared minus 16x plus 64. Two numbers that multiply to give me 64 and add to give me negative 16 are negative 8 and negative 8. Now I told you I'm going to flip and simplify in the same step. This x minus 8 is going to go to the top since when I'm dividing by a fraction, I flip and multiply by the reciprocal. So I'm just going to leave that x minus 8 alone. I can't simplify it any further. On the bottom is this x squared plus 5x plus 6. That's going to get down here. And I'm going to simplify that in the same step. So I want numbers that multiply to give me 6 and add to give me 5. That's x plus 3 and x plus 2. So in the same step as flipping, I've factored the same time to make sure I can combine those steps and save some time. Now I can cross out what I have in common in the top and the bottom. I have an x minus 8 here, an x minus 8 here. I have an x plus 2 here, an x plus 2 here, an x minus 8 here, and an x minus 8 here. Well, if you take a look, everything in the top completely canceled. Well, what's left up there? When you're canceling, you're really doing division. So when you're crossing out the x minus 8 and x minus 8, you're really creating the number 1. And so if everything cancels out in the top, you're left with a 1 in the top, and I'm left with an x plus 3 in the bottom. And there's the completely simplified rational expression after doing the division, flipping, and multiplying by the reciprocal. Now, if we look at number 3, it's a little more complicated. It is a fraction on top of a fraction. To many students, this looks very, I would say, scary. But what you need to remember is you have done these problems before. You're taking this fraction. You're taking 6y squared minus 6 over 8y squared plus 8y. And you are dividing by 3y minus 3 over 4y squared plus 4y. That's what this means. I'm taking this fraction and dividing by this fraction. So if I write it instead of vertically, if I write it horizontally, well, what do? Well, this is simple now. I'm dividing by this fraction, so I know I'm going to have to flip this fraction over here and change it to multiplication, because when you're dividing, you multiply by the reciprocal. And I'm going to have to factor. So let's work on factoring. First thing I see here is I have a GCF of 6. So I'm going to take that out. And I get 6 times y squared minus 1. On the bottom, I have a GCF of 8y. Factor that out, I get 8y times y plus 1. And at the same time as flipping this fraction, I'm going to factor. So this 4y squared plus 4y goes to the top. It has a GCF of 4y. I'm left with y plus 1. The 3y minus 3 goes to the bottom. Factor out a GCF of 3. You have 3 times y minus 1. Now, this is not completely factored yet. Just because you do one factoring technique does not mean you're done. If I take a look, I have y squared minus y right here. And so that can get factored further. This is a difference of squares. And so above it, I'm going to write out the factored form of y plus 1 and y minus 1. And that allows me to simplify even more. So what do I have in common? I have a y plus 1, a y plus 1. I have a y minus 1, and a y minus 1. And I'm just going to leave it as is and try and combine it to make it look nicer and see, can I go further? I have 6 times 4y, which is 24y. And I have that y plus 1 from the difference of squares. I have 8y times 3, which is 24y on the bottom. Well, what else can I cancel out? Well, they have a 24 and a 24 in common. They also have a y and a y in common. So my final answer, simplified form, is y plus 1. And so for many students, when you're given a complex fraction, and that's what we call a fraction on top of a fraction, a complex fraction, written vertically, it helps them to write it out horizontally, and then they see the process. Now, there is a visual shortcut in a way. I have a funny saying to help out, but you can actually draw some arrows to make it easier. And that is the bottom of the bottom goes to the top, and the bottom of the top goes to the bottom. Because if you take a look at this step right here, you really took your 6y squared minus 6 and multiplied by your 4y squared plus 4y. You really took the 8y squared plus 8y and multiplied by 3y minus 3. And so if you can remember, you connect the outsides with multiplying, and you connect the insides with multiplying, you'll be able to set it up right away without writing it out horizontally, and multiply and simplify from there. So this is how you divide rational expressions. If you can divide rational expressions, you should be able to multiply, because that's the process you use for dividing. You flip the second fraction and you multiply.